Welcome to the Unriveted podcast, where we talk about technology initiatives such as artificial intelligence, digital transformation, and people. Today, we're going to put up a nonprofit into our podcast to mention. It's called 10,000 Degrees. And 10,000 Degrees, they have a mission where they envision a world where all students, regardless of race, ethnicity, and socioeconomic background, will have a full range of educational opportunities, support, and resources to realize their full potential. With that, I'll put that information into the write-up of the podcast. And John, would you like to introduce our guests?
All right. Thank you, Martin, for that. Today we are joined by the co-founders of SuperDuperDB, Timo Hageman and Duncan Blythe. And as soon as I said I wasn't going to mess up your last name, I think I did. So my apologies. But Timo and Duncan are our special guests today. They're going to walk us through and talk to us about SuperDuperDB and how it fits into the ever-growing landscape of artificial intelligence. So Timo and Duncan, thanks for being with us today. Martin said, as I'm sure you're aware, we like to keep things very conversational and free form. So I'll turn it over to both of you. And if you want to give us a brief introduction on your background, your experience, and obviously we'll turn the topic over to SuperDuperDB, that would be great. So welcome, Timo and Duncan.
Sounds good. So my name was nearly correct. So it's Hagenow, whatever, however you want to call it. Hagendas. We had Hagendas before. Yeah. So what can I tell you? I'm actually not an engineer. I'm not a data scientist, but I happen to be a founder pretty much all of my career. So I was many years in edtech, but then I co-founded an AI company together with Duncan and another friend. Back then we would do e-commerce AI search and navigation, and we would kind of be confronted, or even you could say overwhelmed with the overhead which comes with standard MLOps solutions, and that made us develop our own internal tooling and development principles which we would implement just really to overcome data pipelines. And ultimately that's what we're now kind of productionizing, and we want to give back to the community that tooling we would have developed, which is instead of bringing data to the models, kind of building these pipelines, it's pretty much bringing the models very close to the data, to the data storage, and that's what we're doing with SuperDuperDB.
So how did you align with Duncan on doing SuperDuperDB?
That's a broad question. How did we align? So actually, Duncan and I, we were introduced through a friend, like over 10 years ago, and we've been just friends for many years. At some point we decided that we definitely want to do something together, and me coming from edtech, Duncan actually maybe Duncan, I'm introducing you now to some extent.
Right.
Duncan coming from industry, basically from pretty big e-commerce player, and we said, like, look, we actually wanted to create an AI innovation lab. That's what we wanted to do. It's really where we focus on technological development, creating nice prototypes, and just see how we bring them to market. And we ended up focusing on e-commerce, but we really saw like this big opportunity with this paradigm changing solution, which we now have with SuperDuperDB, which is kind of eliminating this whole paradigm of moving data and creating pipelines. And that's how we kind of already we're on a journey since Duncan, how many is it? 5 years now. So
5 years, yeah. 2018, 6 years, yeah.
So Duncan, tell us a little more about yourself. It'd be always great for our audience to know who you are.
So where I live, I'm from England, obviously, but I live in Germany, and my name is unpronounceable in Germany because it's B-O-Y-T-H-E, Blythe, but Germans pronounce Y-U. So Y is a U, and THE gets pronounced not as like a one syllable, but it gets pronounced as a new. So instead of Blythe, I'm called Bluter, which means flower. I'm Duncan Flower.
Actually, that's a small anecdote because my Siri is on German. So whenever I say call Duncan Blythe, it's like it always understands Duncan Live. And I don't have a Duncan Live in my phone. So it's always
I mean, yeah, exactly. Yeah, so exactly. So yeah, how did I get to Germany? Starting startups in AI. Yes, I originally studied mathematics in England, and after looking around, I was reading a book where I read that you could do stuff with math and the brain, and that sounded kind of interesting. So I got fascinated by that and found my way to Berlin, which is where they had a new program focusing on ML, so machine learning, AI, and computational neuroscience. And at that time, computational neuroscience was the thing people were excited about. And it all came out to nothing. And luckily, I chose the other thing, which was ML, which was kind of dry and technical.
Mm-hmm.
But now it's kind of taken over the world. So I was lucky to make that decision. And fast forward, I did my PhD, postdoc, moved to industry, and in Germany is kind of, it doesn't have these big tech companies like the rest of the world does. And so for me, like founding a startup was just a way to do really interesting, cool, technical things with AI before we hit this massive hype trend, essentially. And I just like in my immediate environment, there weren't many entrepreneurs starting companies, even though we knew what was going on in like California and so forth. But since I knew Timo through my circle of friends, and he made the whole thing around starting a company seem much less problematic than I imagined. It was kind of a blessing to know him, and now I guess I'm an entrepreneur too. So anyway, so SuperDuperDB was exactly, and he told the rest of the story. It wasn't just to do with me; it was also to do with this was a unique opportunity to bring the world of software development, infrastructure, ML, and AI into sort of a unity, which I think is quite fascinating.
So is this your first time in the entrepreneurial world, Duncan, or have you been around before?
No, my second time. So Team and I already had one startup before this, which we founded in 2018, and we ran that for a couple of years. So this will be our second startup. Yeah.
Great. Well, let's jump into SuperDuperDB then. That's the theme of today. And, now it's the time that Martin and I pepper you with questions at rapid fire pace and you have to keep up.
All right,
I promise it's not going to be like that. But so, we've done our research, obviously, and know a little bit about your product, but there's no better insight than from the developers and founders themselves. So one of the things that I notice about SuperDuperDB is that it isn't an actual database. It makes your existing database super duper. So
Yes.
if you care to explain how that works and what that means, I think that's pretty interesting.
Yeah. So pretty much SuperDuperDB, what it does, it transforms your data store into an AI development and deployment environment, kind of, right? So we're really trying to eliminate this whole paradigm of moving data away from the data source, because ultimately all enterprise AI use cases and applications are based on proprietary data, which is stored in some kind of data storage or data storage system, and ultimately you don't want to move data away and deal with data management overhead. You just want to use AI, right? You just want to take models and kind of install them onto that system and allow the models to interact with the data which is stored in these systems, and then that's ultimately what we're doing. So you're right, it's not in fact not a database, and it's kind of misleading, but going forward we are trying to kind of lose the DB along the way.
Gotcha. So I mean, it's kind of like, and I don't know if you guys played this game as a kid, and maybe I'm dating myself by saying this, but it reminds me of the telephone game where one kid starts with a message and then whispers it to the next one and then whispers it to the next and back. and then you see what the original message was or you see how that message got transformed from where it started to where it ended. And I can kind of see that, as a analogy to what you're trying to do is, the more that you move data away from where it came from, different things can happen along the way, some intentional, some unintentional, and then who knows what comes out the other end. So I assume that that's kind of one of the ways that you look at why SuperDuperDB, or just SuperDuper, I guess we can call it.
Exactly. We can also settle on super, right?
Right.
No, exactly. I mean, that's exactly that, right? I mean, it's kind of tedious to call all these different people in a chain. Rather, you want basically have all the people to be informed, if you want to take that metaphor. But it's exactly
Right.
that.
Yeah. Right. Now, thinking about the data challenges for AI systems in particular, right? So data is obviously nothing new in this world here. Machine learning has been around for decades, but AI is kind of a new, it's setting a new paradigm, right? Where we have vector databases and we're using text and images and other sorts of unstructured data that we didn't always used to use. So, we were kind of stuck in numerical data. And now we have, numerical representations of things like text and images. So I'm kind of interested in speaking a little bit more about SuperDuperDB and how it works with vector databases, or how it improves vector databases, since those have become quite the rage in the past, year and a half or so.
Yeah. So, I mean, there's this concept of introducing a new vector database, which is basically, okay, maybe one step back. So when we talk about vector search, which is kind of this breakthrough, data search and navigation solution, we have to really talk about two different things, right? One is actually the vector store, and one is actually performing, comparing these different vectors in this vector space, which is kind of vector search, which is to be understood as a vector search engine, right? And now in the last years, you had these new solutions coming up, which are called vector databases, and it's really a question if it makes sense that you have a dedicated database, although your existing database is perfectly capable of storing large numbers, right? Like, and what happened then after this initial rise of vector databases, that the existing major databases kind of introduced native vector search or vector search engines to their offerings, right? So we have now MongoDB Atlas, which is the managed service of MongoDB, offering Atlas vector search. But now it's the second most used vector database. Now you have I don't know, things are moving fast. I don't know, even PG Vector or Postgres, or PG Vector for Postgres should be widely distributed by now. And it's really just a question, like, do you really need a dedicated specialized database or vector store just for these use cases? And I think there will be very few use cases, although there will be some, right? So there's definitely demand for that. There's a good reason why they exist, but there will be very few use cases where you really need a highly optimized setup where you have a dedicated vector database, because you have really high or large amounts of data where the use cases actually provide business value. It's more like a shiny demo, but where really the use case provides value to an end user, to a human end user. And it's kind of the question. So ultimately, our thesis is this: it's just a question of time until all usual databases will provide some kind of vector search engine, and that's what we're seeing already, right? But so the question remains, how to efficiently, in a structured way, which you can manage going forward, how to generate vector embeddings of your data. And the question remains, and of course, some of the vector databases, they provide embedding methods and models off the shelf. But for the others, it's still the paradigm of kind of taking your data out of your database, like throwing it against an API, embedding API like OpenAI, or hosting your own embedding model, and then kind of generating embeddings of your data, and then retrieving these embeddings and storing them back into your database. And that's exactly where we come in, because we just make it very easy and effortless to install models onto your database, and embedding models are just a special type of machine learning models. So it's exactly that, right? You can literally just take a model on API, connect it or install it on your database, just simply with the query define your input data, which you want to create vector embeddings for, and then just create embeddings, which you can then index with your vector search engine, and then you can perform vector search very easily.
Perfect. Martin, go ahead. I've been taking all the time up for my questions.
It's all good. So we know that you've introduced that as an open source project. Can you talk about the traction of the open source today and the potential to get to monetization?
I mean, we've been really surprised even by how well it was received, right? So we started we uncloaked the code base late autumn last year with initial support for MongoDB, because Duncan and I in our previous company, we were doing everything with MongoDB. We're great fans. But anyhow, we launched version 0.1, which is quite conservative, of course, with support of major SQL databases. And the launch itself was so well received. I mean, we put it on Hacker News, and we wrote a launch blog post and put it on some platforms. We actually didn't spend any marketing budget, but we ended up trending on GitHub globally for a week straight. And really the traction we see now it's really just a product of the last 2 months, pretty much. Actually, today is the 5th. I just realized now, so it's exactly 2 months. So yeah, the feedback has been just awesome, actually. So people understand the value proposition. I mean, of course, when you're dealing with an open source project, the README itself, you have to put a lot of effort in the phrasing and how you want to put things. But people really get it, and also I think this pain points we are trying to solve, many people deal with it on a daily basis, right? So when you look at not just Gen AI, but also standard ML use cases, there are a lot of shiny demos, there are a lot of great prototypes you see all over LinkedIn and so on. But the problem is, like, how do you get these into production in environments where you have to deal with constantly changing data, right? Where you have to keep your deployment, the applications up to date when there's new data coming in all the time. And I think that's a big problem. And this is exactly where you rely then on these ETL processes and pipelines and batch updating overnight and whatever, all these different things. And it's kind of, for me, not being in this as an engineer, as a practitioner for decades, it's so unnatural, right? It really doesn't make sense that it wasn't constructed in a way we kind of constructed now, with streaming inference and kind of models listening to data changes in the place where the data is stored. Yeah, that's it.
I know people always say that AI is going to take jobs, and that's a very flat way of putting it, right? There's so much more nuance to it than that. But thinking about the paradigm shift that you're pushing forth with SuperDuperDB, would you say that SuperDuperDB in its current form, or however it may evolve over time, could potentially eliminate certain roles that exist now in the development of AI pipelines, like data engineering or anything like that? Hopefully that makes sense.
Yes, no, most definitely. Actually, also, Martin, what you said about commercialization, exactly. This is exactly the intention, right? To really eliminate all of the overhead which is involved with these concept of pipelines, right? Of moving data and making sure data is, of course, data is always going to be brought to the models, but it's the question: should this be a task of the engineer, right, of the DevOps guys, or should this happen just naturally under the hood by systems, by intelligent systems, and we kind of make these abstractions and these design decisions for the developer? So
sorry, listen, we're not trying to seem too keen about the idea that people might have less to do in certain areas. I like to think of it more as that, like, people are going to have their time freed up for actual creative work, and for me, so as a data scientist, the creative part of being a data scientist is the actual abstract algorithm part. And for that, we're actually trying to furnish the technical person with more freedom, because they're less focused on this dry and rather tedious part. So maybe there'll just be more good work done.
That's what we hope. That's what we hope.
Yeah.
Lots of good work. As
Yes.
we wrap up here, we try to keep these sessions really tight. But as we wrap up here, maybe Duncan, we'll start off with you. If you had to give advice to yourself as a younger you, is there anything you would do differently in your career coming into this point than you have already accomplished?
I mean, I was pretty lucky to have studied something I was really interested in, and then sort of fallen in backwards into something that turned out to be society changing. So no, I would say keep doing what you're doing.
That follows the line of follow your passion, and it feels like you're not working.
Yeah, I guess.
Yeah.
I tell you, I'll tell you one thing. I'll tell you one thing that I would have told my younger self. I would have said, there's this neural network thing, it doesn't work very well. Keep thinking about it, because it's going to work really well. Just give it a chance and be the first, be an early adopter. Don't be like in the second wave of adopters like I was, which was also nice.
That brings up, you know what? That brings up, I know we're going to cut it short, but I just wanted to throw this one in there because I like this question. Thinking about neural networks, right? And thinking about transformers, which is essentially, transformational, pun very much intended for what we see with large language models. What do you think the path forward is for improved artificial intelligence system? Bigger models with more parameters, like we see all the GPT models with billions, trillions of trainable parameters, or a new discovery, if you will, in model architecture, just kind of like the transformer was not really a discovery, but does that make sense? I'm interested in what you guys think about that.
So maybe I can take that one. So obviously we're not going to stop, because compute is getting cheaper and there are more competitors on the market, and parallel multi-machine computation is becoming much easier and faster via software and optimized algorithms. So that's not going to go away, and so we're going to get some progress via that route. But I still think like the consensus is that these machines don't recognize concepts and so forth like we do. And I was privileged to watch a real learning machine in action this last year and a half, because I had a daughter. And one thing I noticed that she was able to do very early, which I know that machine learning algorithms can't do, was take something like a dog, recognize a real dog, and then know from seeing a few caricatures in cartoons that that's also a dog. So if you take an algorithm, what they do is they go into the vector space and they're looking for very similar looking things. But if you actually measure the similarity between like a really poorly drawn cartoon of a dog to an actual image of a dog, like in these vector spaces that people are now researching and implementing with vector databases, they're nowhere nearly close to each other. They're only close to each other in the sense that there's a concept which is much more important than the actual visual similarity. And even very, very small children are able to go to this concept and then start calling things dogs and cats. And they do what we exactly weren't taught to do when we were learning machine learning, which was to try and describe what a dog is. Like a dog has these two little ears and it's got these eyes and the tongue sticks out and it makes a bark. Right. And that was it. Don't get, if you're designing an intelligent system, don't get into those. Don't try and like make rules. And that's the first wave of AI trying to do that, because so I'm convinced that, and I think that's also a consensus now. We're starting to get the law of diminishing returns on like throwing huge compute at these problems, and there are going to be new ideas which come in. So very exciting.
Perfect.
Excellent. So we're going to call this a wrap for the Unriveted podcast. On behalf of John and I, we want to thank you both for joining the Unriveted crew. Thanks all.
All right. Thanks, guys.
Pleasure.
Thank you. Bye-bye.
Thanks for having us.